Swayam Prabha. Digital India. Educated India.
Welcome back to Aircraft Structures 1 course. This is Professor Anup Ghosh from Aerospace Engineering Department, IIT Kharagpur. We are in the third week lectures. This is the last lecture of the third week, lecture 16, wing truss system. Today we will solve a small problem considering a wing truss. Even we will not solve the total truss system, a part of the truss system, 3D truss system we will be solving today. Introduction as a recapitulation, what we have already done, we have learned some history, we have learned how the structures are, the fabrication or to some extent details of aircraft structures. We have learned how load comes into the structure, and we have learned the what is load factor, ultimate load, limit load, all those things. We have solved problems how the wing experiences bending moment and shear force, as well as fuselage experiences bending moment and shear force. And in last 4 lectures we have learned first simple truss system, and later on we have considered the problems of landing gear as 3-dimensional truss structures or truss system. So, we will move forward to today with a wing lift truss, solving of wing lift truss. Let us see how it is done and how do we solve the problem. This type of wings are used for amateur aircrafts, for various clubs, by various clubs, and for amateur flights. So, let us see how do we solve the wing truss. Find the loads on the lift truss members. Lift truss members are these 2 member truss. This is a member lying on the plane, which is if we better to have a direction. This is y direction, this is x direction, and the up direction, that means this direction is z direction. So, this is, I think is better to draw here y, this is x. So, we can say that this view what we see is on the x z, and this view what we see is y z. Okay. With this consideration, we will move forward to solve the problem. Find the loads on the lift truss members of the wing configuration, considering only lift on the wing. Drag truss, this truss system is the drag truss system. Drag truss members of the externally braced monoplane wing is shown. This is the external brace members, these things we are supposed to find out. The air load is assumed to be uniformly distributed along the span of the wing. The air load is uniformly distributed, as it is mentioned, it is 20 pound per inch along the length. The diagonal drag truss members are weirs, these members are weirs with the tension diagonal effective and the other diagonal carrying no load. So, only one is under tension, whereas the other side is not is not having any tension. The vertical load 20 pound per inch is distributed to the spar in inverse proportion to the distance between the center of the pressure and the spars. These are the two spars, this is one spar and this is the other spar. So, this member is joined to this spar C G and this member this C E is joining or supporting the spar B E. This C G is supporting the A G spar and C E is supporting the B E spar. The load on the front spar is therefore 16 pound per inch. It is assumed as mentioned here inversely proportional. So, that is the reason the front spar is carrying 14 pound per inch and the rear spar is carrying 4 pound per inch. So, let us see how do we solve the problem or find out member loads in the member C G as well as C E, that is our task. We are supposed to find out the member force in C G and C E. Okay. Here we have the first or the front spar, where as it is already discussed 16 pound per inch load is distributed uniformly. This distance is 10 inch, this is the total 180 inch and we have a member that is from C to G. This is the point G. The front spar is considered as a free body as shown. The vertical forces at A and G may be obtained with respect to a moment of summation of moment at with point A and minus what do we consider is that we are considering the free body of the member C G 16 into the total load coming, considering this member about point A we are taking moment. So, this 180, the C G is at 90 distance, 16 is the UDL uniformly distributed load concentration and the vertical load G is acting there, that is to support. So, from that way moment about x axis at point A, moment about x axis about point A we are considering and that gives us the load C G as 2590 pound. Considering no drag force in x direction is acting on the joint G. So, if we consider this joint G and taking moment about x axis at point C, considering the member C G, what we will get is that this is 60 and this is 100. This is 60 inch, this is 100 inch and the two forces are acting, one is downward as G Z and the other force acting here as G Y. So, if we solve this in this direction, we have in the opposite acting to moment and from there we get that G Y is equals to 4320 pound. This is the complete solution of the drag brace. We will discuss this again, but here it is to note that this 4320 pound which is coming to on the member C G, that is also acting in this direction as 4320 pound here, and the other force we will discuss in the next slide. Okay. So, in this slide what do we have? If the rear spar is considered as a free body as shown in the figure, MB or the moment about x axis at point B. If we consider, what do we have? Like the previous one, we have only the load intensity changes, otherwise there is not much change in this equation, it is similar to that. So, we get the force E z is 648 pound as it is shown here. Considering no drag force is acting in x direction at the joint E and taking moment about x axis at point C, considering member C E, this member C E, what we have similar way as we have seen in the last one, that C E, here also we have this force and this force, this is equals to E z and this is E y, and then accordingly what we can find out that E y is equals to 1020 pound. This is C, this is E. One more force is there, but it is in the same line of x direction, that is why E z is not considered. And again, considering no force is acting in y direction at the joint E and taking moment about y axis at point C, what we can find out that E x multiplied by 100 in the other plane, if we consider E x multiplied by 100 and E z multiplied by 30, and we get the E x value. So, this is a similar visualization like this, and we get the value of 324, and this 324 contribution we will see in the, this is the force 324 acting towards from the board towards me, and that value is 324, here it is acting. So, we need to consider the other direction moment to find out that. So, with this consideration both the members C g and C e are found out. In case of C g, there is no force in the x direction, whereas for the C e there is a force in the x direction. With this understanding, we also come to the last figure, where as we have mentioned in the last slide, the found out force of G is shown here, and that 324 is getting added up here. See, this is 100 plus 200 gives 300, then 200 plus this gives the minus 824 pound in this vertical member. So, that is the reason that E x, this direction force, which is 324, is added up and increases the drag member force. So, with those force combinations, as it is drag members are there, you can easily solve. The answer is also given. So, you can solve the problem and find out the forces. Please note, the addition of y and x direction forces at joint G and E. In x direction force is added 324, in x direction force is added with 324 pound at the third member from tip of the wing, and the adjacent members are added with 4320 pound and 1080 pound respectively. This is the 1080 pound as it is shown. So, with those member forces added, we are supposed to solve the drag truss of the wing. With this we conclude the third week lecture series, and with help of the space structure system, we have solved a few problems of aerospace or aerospace structures. There are many more problems to solve, but with this introduction I hope you will be able to attempt the day-to-day problems of aircraft structures and will be solve those problems for further analysis. So, with this I thank you for attending the last lecture of third week. We will start a new topic in the fourth week. Thank you for attending the lecture.